system. Already I explained what is gating, what is gate, what is runner, what is riser. All these things I have already explained. Once again we will go, because this is a separate system which is to be designed properly in the mold. So what is a gating system? Gating system means while producing the casting, we collect the molten metal from the furnace. That molten metal we have to pour into the pouring basin or pouring cup. That liquid metal, molten metal, will be added in the pouring cup or pouring basin. That liquid metal flows down through sprue, through the sprue. It is made slightly tapered. Already I have told you why it is made taper. Because if it is made taper, it is easy to remove the pattern. If it is not made taper, it is difficult to remove and it will get damaged. So therefore, the allowance is given. So the taper is given like this. So this is the pouring cup. Liquid metal will be added here. So the liquid flows down through the sprue or down sprue or down gate. Through this it will come down. Once it comes down, then you can see there is a long channel. This one. This is the long channel through which the liquid metal flows. It collects from here and then it flows like this. This is called as the runner. A channel through which the liquid metal flows. And this is the casting. This is the mold cavity. This is the mold cavity. This mold cavity should be filled. For filling this mold cavity, depending upon the size of the mold cavity, bigger mold or bigger cavity or smaller cavity, depending upon the size of the cavity, we are providing the entry gates. See here, gate number 1, gate 2, gate 3. 3 gates are there for this cavity. If the cavity is small, just 1 gate is enough. Cavity is still very big, then more gates are required. More than 3 gates are required. So depending upon the size of casting, the number of gates are provided. Depending upon the size of casting, this runner is also provided. So big runner for big casting, small runner for small casting. Like that, this has to be properly designed for filling of this liquid metal. What is the size of gate required? What is the size of runner required? What is the size of sprue required? So all these things are to be properly designed for better production, for efficient production. Otherwise, more wastage will be there or more defect will be there in the casting. So to avoid any defects in the casting, it has to be properly designed. Then one more thing is the riser. See here, you can see the riser. What is the function of riser? So first the liquid metal is poured into this basin. It will come here, it will come down, it will flow through the gate like this. It will flow through the runner like this. And then meantime it enters through the gate. It enters through the gate like this. And then it fills the cavity. It fills the cavity, empty space. So that we cannot see this filling and all. We cannot see whether the cavity is filled or not. So once this is full, then the liquid metal start rising here. It will start rising. As you pour here, the liquid metal rises here. So this portion and this portion are at the same level. This and this are at the same level. So therefore, when you are pouring the liquid metal here, it is rising to surface here. If it rises to surface, if this liquid metal come to surface, then it ensures that this portion is completely filled with liquid metal. There is no empty. There is no cavity filled, left unfilled. So it is completely filled. So that this is ensuring. Okay, this riser ensures that the cavity is completely full. Okay, that is one function of the riser. I explained in the previous class one more function of the riser. What is that means? When the liquid metal is cooling, this is the liquid metal cooling. Initially, this is the volume of the liquid metal. Then what happens? Gradually, when it is cooling, losing the heat, the contraction of this metal takes place. Size of this will be getting reduced. Contraction takes place. So, but we want the casting to be of this size only. Size should not get decreased. For that purpose, whatever the excess material required, that will be supplied here. Liquid metal is present here. That liquid flows into back to this, so that this will solidify with proper dimensions. So this does serves two purpose. One, to ensure that liquid metal is completely filling the cavity, and the other one is it is serving the purpose of supplying the feed material or the liquid metal during solidification. Two purpose it will perform or it will serve. So these are the various components of the gating system. Pouring cup, this is the sprue, down sprue or just sprue, and then this is the runner for the purpose of allowing the liquid to flow, and these are the gates for the purpose of allowing the liquid to enter into the mold cavity. This is the mold cavity, and this is the another gate or back gate. These are the front gates. This is the back gate. Back gate means what? The liquid metal after filling, it will rise into the riser. There is a riser here, so that it will serve two purpose as I told. So this is the entire gating system. Here you do not have any design aspect. You do not have any design aspect. But when you take this as the subject, as the special subject or elective subject, you can study complete parameters design. For this much size casting cavity, what should be the gate size? What should be the runner size? What should be the sprue size? What should be the riser? How many riser are required? How many gates are required? All these informations you have to physically design if you take the course, this subject as an elective subject in your final year. Okay. These are all I already explained. So principle of gating system. What are the principle or functions? Principle nothing but almost they are the functions. What are the functions or principles of gating system? A good gating system should help easily to complete filling of the mold cavity. Complete filling of the mold cavity. Therefore, it has to be properly designed. It should fill the mold cavity with molten metal with least amount of turbulence. See, you have to take care of these things. What is the meaning of turbulence? In fluid mechanics, you are studying this laminar flow, turbulent flow, etc. This is also fluid only, liquid metal flow is fluid mechanics. So turbulent flow means the fluid particles, they will not flow in straight path. They will be flowing in a disturbed pattern. Particles will be flowing in a disturbed pattern. They will be rotating during flow. It will not be continuously straight line flow. So therefore, that type of flow is called as turbulent flow, violent flow. So because if it causes violent flow, then the sand erosion takes place. It should be laminar flow. Laminar flow means flow just like if you pour some castor oil on the surface, how exactly it slowly flows. That is the laminar flow. And then water flowing in a channel with high speed, that is the turbulent flow. So if it is turbulent flow, it creates lot of problem, lot of defects. Therefore, it has to be laminar flow. In that way, it has to be designed properly. It should prevent mold erosion. If turbulence is not there, erosion will not be there. Okay. It should establish proper temperature gradient in the casting. Temperature gradient means difference in temperature. What should be the casting temperature? What should be the gate? All these things properly designed. It should promote directional solidification. This topic already I have explained. What is the meaning of directional solidification? Directional solidification means in this casting, so riser should be the last portion to solidify. Runner, riser and this sprue should be the last portion to solidify. First, we are the mold. This liquid metal in this mold cavity should solidify first. Then riser and this gate, etc., should be the last to solidify. First, it should not solidify these gates and other things. If the gate and runner, riser solidify first, then mold cavity solidify last, then what happens? The proper casting we will not get. So therefore, directional solidification means the required part should solidify first, then remaining part like riser, screw, etc. should solidify at the last. So like that, the design should be there. So these are all the design consideration of the gating system. It should regulate the rate of flow of metal into the mold cavity. If properly designed, this rate of flow depending upon the size of casting, size of mold cavity. Bigger the cavity, larger the rate of flow. Smaller the cavity, smaller rate of flow. Like that, it has to be properly designed. So therefore, these are all the important points to be remembered forever while designing the gating system. So gating system means what and all we consider? We consider the pouring cup, then screw, then runner, gates, riser. All these things are very important and all these are to be properly designed. That is the principle of gating system. Types of gates are there. We can place top gate, bottom gate, parting line gate, step gate, etc. Okay. So as the name itself says, where the gate can be placed. If it is at the top, okay. If it is at the top, then it is top gate. If it is at the bottom, then it is, see here it is top gate. The liquid metal is directly poured into the mold cavity. There is no runner, there is no riser, there is nothing. Okay. So directly molten metal is poured, it is called top gate. It is not always advisable. This is not advisable. Then bottom gate. See, we pour the liquid metal here. This is actually the mold cavity. Then liquid metal comes here through the sprue down, runner, then gate. This is the in-gate. This is the bottom gate. From bottom, the liquid metal enters into it and rises up to this. This is the bottom gate. Okay. Then another one is parting line gate. What is the meaning of parting line gate? Means see, this is the cope and bottom one is the drag. Along the parting line, parting line means between two junctions, between two boxes, or between cope and drag, between these two. This is a line. This is called parting line. So along the parting line, the gates are provided. See here one gate and this is the other gate. Two gates are provided. This is the riser, this is the runner. So liquid metal is coming like this and filling here and then it is rising like this. So like that, this is the parting line gate. Along the parting line, the gate is provided, then it is called as parting line gate. Next is the horn gate. Horn. See, the gating system is provided like this. See, it is not directly flowing here because again it is the just like bottom gate only. It is the liquid metal is entering from the bottom like this. This is the gating flow. This is the horn gate because the liquid metal if enters here, this is the part. This becomes the parting line gate. If it is parting line gate, what happens? The liquid metal comes here and then it immediately, when it drops into this cavity, the erosion of the sand particle takes place. Therefore, slowly the liquid metal should rise like this. So therefore, this is the horn gate. This is in the shape of horn. It is called horn gate. These are all the different types of gates. Gating systems are types of gates. Top gate, bottom gate, parting line gate, horn gate. Like that, types of risers. Types of risers. There are two types of riser. This I had explained in the previous I think second or third class. Open riser and the other one is the blind riser. What is the meaning of open riser? See this diagram, you can see this is the This is the sprue cup or pouring cup. This is the sprue. The liquid metal is going down like this, and then this is the runner, and this portion is the gate. This is the cavity, and this is the riser. So open riser means the riser is open to atmosphere. This portion of the riser is open to atmosphere. It is called as open riser. An open riser is a riser provided in the mold cavity when the top portion is open to atmosphere. Okay, this is called as open riser, so that we can see these things. But what happens? This, if it is open to atmosphere, this portion of the liquid metal solidifies because this is transferring the heat to atmosphere at a faster rate, and lower portion of this will be in the solid liquid condition. Okay, so this is the open riser. And the other one is blind riser. What is a blind riser means? You can see the liquid metal is poured here, and then this is the sprue, this is the runner. Here you can see the blind riser. This is blind riser. So now the liquid metal first fills this cavity. This is the cavity, it fills in this cavity. So during its filling, so as and when as it rises in the cavity, it also rises in the riser. And it is blind. Why it is called blind? This is not open to atmosphere. This is not open to atmosphere. Above this riser there is mold. So therefore it cannot be seen outside. It is called as blind riser. What function it will serve? It will supply the liquid metal required during solidification. I already told you that the liquid metal contracts during solidification. It requires additional amount of liquid metal. That liquid metal will be supplied by the blind riser. This is the portion which is last to solidify. This portion, blind riser, and this sprue will be the last portion to solidify. This casting solidifies first. So this is the blind riser. So open riser and blind